Excellent. Thank you so much, Merritt. And good afternoon, everyone. Thank you for staying until the end of this wonderful day. I think it's fitting that we began the day with the big picture of the global economy, with major companies speaking, with business giving their perspective. And we're going to end the day with my very tiny company and really an individual perspective on what we do as geologists and how we're going to interact with the new energy economy. It's been delightful all day as I've listened to each of the speakers to hear some of the thoughts that I'm going to share with you reflected in others' discussions. And I think that's quite illuminating that you're going to get a perspective from a plain old geologist from Tulsa, Oklahoma, that has some things in common with Sir Mark's remarks this morning. So it's quite an interesting little picture in that regard. My first slide is a picture that I took in Cusco of the famous 12-sided stone. And I put this up in the beginning to sort of emphasize this unique quality that we all have as geologists, and most particularly as explorationists, that we, to paraphrase Emerson, we are not happy with just following trails and processes. We like to go where there is no trail. We like to explore the uncharted frontiers. We're unafraid of risk. We love a challenge. And what could be a greater challenge than to find ways to economically implement new forms of clean, green energy? So I'd like you to kind of keep this in mind. These Incan stonemasons didn't just make the easiest chips into their rocks to build these walls that stood up for 500 years, even to the Catholic Church coming in and raising the Incan temples. They built to last with what at that time was very new technology. I also come to you today as a representative of the Energy Minerals Division of the AAPG. Now, the Energy Minerals Division is the group within the AAPG which, since its founding in 1977, has been charged with pushing that frontier. We look at everything that is kind of outside of the traditional oil field. So we look at uranium, we look at coal bed methane when that was new and different. We looked at unconventionals when they were new and different. And today we have critical minerals, gas hydrates, all sorts of committees that look beyond petroleum, if you will. So we are sort of the explorationists of the AAPG beyond petroleum. But I also bring to you today the recognition from, again, that many of us have used these words as we've given our presentations, that what we do as energy geoscientists has not changed and really will not change in the new energy economy. We work to ensure access to affordable, reliable, modern, and sustainable energy for all. That's a job description that I could have used 30 years ago when I was working for Amoco, and I can use it today as I work with my little battery tech clients. So this is what we do, and if we can kind of keep that at our heart's core, then we can look at the energy transition as providing new opportunities rather than shutting doors on old ones. So this slide I put in, it's a little bit cartoonish. It's kind of a layman's slide. But the reason I included it is I used it a few days ago in Tulsa, Oklahoma. I gave this presentation, or a much more generic version of it, to the Tulsa County Democratic Party luncheon. And as my husband said, oh, that's so good that we have one. But most importantly, it was just a wonderful way to kind of familiarize the layperson with someone who lives in the oil patch, with what's going on in the US with this change in the energy economy. And I used this slide because it's sort of a depiction of how we take sunlight, it's transformed through a variety of biological and chemical processes into petroleum, it's stored in the subsurface, and then, as most people think we do, we just stick a soda straw down there and grab the oil out of the ground and stick it in the car. So this is what we've all done for all of our careers, right? And most of us have been focused on this little bit of how the oil is trapped and accumulated underground. And we're very comfortable with that role of energy, taking energy from sunlight and providing it to the public with understanding that piece of the process. But what's happened is this big technology disruption that has changed the fact that instead of having to pull up to the oil pump, now we're looking at that route from the sun to the user as being occupied by this new technology space. So not only was this kind of a handy way to explain it to the Tulsa County Democratic Party, but it was also for me kind of a good depiction of what's really different about what we're doing in the new society. And that is that it's all a function, the business model, the economic drivers are more a function of technology development than they are of that subsurface process that we've been so comfortable with for so long. But I hope I'm going to show you today, and certainly some of our other speakers are, about the details of what we can do within that technology development that relies on those subsurface skills that we developed. So this graph is also, I think, just a very nice piece of eye candy to kind of capture one of the things that I think is most important about looking at what drives the new energy economy. And as an explorationist, the things I've been trained to look for are what is the resource base? What is the size of the pool of resources we're looking for? How efficiently can we use them? And then how economic can we make the process? How much profitability can we drive into the process? So I love this slide. It's from, it's actually the graphics were done by Sun Team Solar, which is a Canadian solar installer. But the data were from a paper by Perez and Perez in 2009 that was published by the International Energy Association. And of course, on the right, you see all the finite resources with their finite reserve numbers, and we can all argue, and I'm sure we will, are those too big, too small, but we would all agree that there is a number there. On the left are the renewable resources, and of course, this is not a story that I need to belabor with you all, because we all know that the finite resources are divided by global energy consumption, which is now at about 20 terawatts per annum, not the 16 terawatts it was back in 2009, that we must divide all of those numbers on the right-hand side of the graph, whereas on the left-hand side, those pop up again annually. And of course, the 800-pound gorilla in the room is solar. If we can capture that in a much more efficient and less involved manner than having to store it in petroleum, then we can use that energy year on year on year at many times, many orders of magnitude greater than we currently need. So let's look next at efficiency. And this is a graph from the National Renewable Energy Agency, a typical lab graph of all of the improvements in solar technology over the past 30 or 40 years. I love this little website called explainthatstuff.com. And they took all that data and put it into something that you can really see that improvement in efficiency. That's that same scale that we saw in the chip revolution in the past century. And now it's happening in the solar world of moving from a few percentages of translating sunlight to energy up to almost 50% efficiency. So this drive to efficiency is one of the things that's propelling the new energy economy. Now, the other thing, of course, there's abundant resource. It's becoming more and more efficient to use it every day. And the other question is always one of economics. And we've all seen, Lazard's studies that publish new graphs, and there are multiple publications from Bloomberg New Energy Finance, et cetera. But I'm a geologist. I like maps. So this is a map of the US, and it is produced by the University of Texas at Austin Institute for Energy. And what's beautiful about this map is it is calculated county by county, and you can also download the spreadsheet and do these calculations yourself to indicate at a point in time what is the lowest cost of new electricity generation. And the colors on this map indicate green is wind is the lowest cost. So you see that beautiful wind belt through the middle of the US. Purple and gray are solar, either industrial or utility scale. And the orange and pink are natural gas. Now this map was generated in October of last year, so it's way out of date. So soon the Energy Institute will generate a new one, and I'll be delighted to see what it shows. But even in the US, where I won't say who called us this, but one of my colleagues said we are the troglodytes of the renewable energy world. Even in the US, you can see that magic triumvirate of the cheapest forms of energy are natural gas, solar, and wind. Nowhere on this map is a county where the cheapest thing to do is build a new coal-fired power plant or even a nuclear power plant. And what I suspect will happen is that wind and solar will take on a lot of the natural gas areas in the coming years. So we all know that along with wind and solar in particular comes the need for storage. And that's the other aspect of this energy economy that brings us back to the subsurface, is this burgeoning supply chain that needs to be developed to feed the batteries that are being built at a phenomenal rate to store energy from wind and solar. So things like graphite, nickel, cobalt, lithium. Graphite in particular is the workhorse of the battery world. Not very sexy, but it is there and it's making up the bulk of these batteries. So the need for new resources, I loved the Equinor purpose, which was, to paraphrase it, turning natural resources into energy. That again is a definition. It doesn't matter whether you're in the fossil fuel side or the renewable side, that is what we do. So just to kind of summarize a picture of what we've been talking about all day, and particularly what we were looking at in that calculator that we played around with, this bulb is just a sort of a depiction of global energy usage. And in general, over half of what we use on a global basis is used in industrial processes, about a quarter in transportation, and the rest for residential and commercial. And what we're seeing is on that industrial side, we're seeing oil and coal-fired power being replaced with solar, wind, and natural gas, as the map showed. If I'm in Chautauqua County, Kansas, and I'm building a Google data center, I want to buy wind energy because it's the cheapest. And then we're seeing a shift in transportation away from gasoline and toward electric vehicles, and hopefully toward GTL. I was really delighted to hear that being discussed, because that's, I think, could be a game changer. So as we make those shifts in each of those arenas are a number of opportunities, whether it's with exploration or production or risk management, and that's what our other panelists are going to speak with you about today. I want to just pick on one that I really love, because it speaks to, first of all, it was the first job I had out of undergraduate, which was working for Anaconda Minerals, doing silver mining in the Coeur d'Alene district. And so looking at where we are going to find the new energy resources to feed the battery tech explosion is something that's very fascinating to me. And it's not surprising. I got this little diagram from Cam McQuaig, who is at the Center for Excellence at BHP. And of course, BHP is in that sort of magical place where they have both mining interests and fossil fuel interests. So they truly are in that double business of converting natural resources to energy. And Cam likes to point out that so many of the processes that we've perfected on the petroleum side are directly applicable and transferable: basin scale analysis, geochemistry, subsurface logging, directly applicable to the mining side of the business. And a favorite of mine is the beginning of the use of 3D seismic to understand undercover, as the subsurface is called in the mining business. And I was at the Society of Economic Geologists meeting in Keystone last year, and John Ashton presented this seismic line from Mississippian carbonates in Ireland in the lead zinc deposits. And they were so excited because they were just starting to look at seismic and trying to identify faults. And I looked at the line and I said, man, you need to talk to my processor, because look at our Mississippian seismic from the oil field, and look how we can actually see the faults without even any lines on the map, and how good our reflector character is. So we have so much that we can transfer in the subsurface from the oil field to the mining industry as these tools are beginning to be applied. Of course, we are also able to do the same with a lot of our technology on both fracking and monitoring and 3D seismic on the geothermal side. And I know that Joya will talk a lot about the details of that. We've also already, well, let me, I forgot I put this slide in. When we get to the GTL question, that's where our expertise in natural gas and our ability not only to find it, but to produce it in a much cleaner and greener mode is going to come into play, because all of the red dots on the map on your right are, of course, gas reserves around the world. But we all know, after drilling dry holes in Angola because they were natural gas, that there's a wealth of resource behind this map that stands to be monetized if we can crack the nut on commercializing GTL at the small scale. And finally, we've heard quite a bit about carbon capture and storage, but I show you this set of pictures courtesy of Autumn Hagsma at Battelle from the Niagaran Reef Trend in Michigan, where they're using everything from core scale, scans of cores, 3D seismic, wellbore imaging to do exactly what we do to take a reservoir apart in the subsurface for carbon capture and storage. I'm gonna have to start taking the U off because I really like that argument. So what about the sustainability of these practices? Well, we've all talked about a little bit sustainability in the mining industry, and it is quite interesting. I can't remember who said this morning that the mining industry is sort of a step ahead of us on this from the petroleum side. And perhaps that's because they're not in the business of producing greenhouse gas. But the thing about the mining industry is they have discovered the enormous economic benefits to going electric, to putting all electric vehicles in the mines. Rio Tinto and Alcoa are partnered with Apple to develop a new technology for zero carbon smelting called ELYSIS. There are also floating solar panels over tailings ponds, which has the double duty of supplying the mine with cheaper energy and also keeping evaporation down in the tailings ponds. But we also know that the challenge is not over. Someone this morning also referred to cobalt mining in the DRC, and the conditions there are truly deplorable. So that becomes the challenge to us as subsurface geoscientists to help in making this supply chain of natural resources for energy continually more sustainable. And as many have pointed out, we have the opportunity to do that in the oil field as well. And to me, this sort of greening of the oil field really serves three purposes. One, it's greener. Two, it's more economic, so it's greener in the dollar sense as well. And three, it allows our geoscientists to become part of projects that look a little bit more toward the future. So things like, I'm working with several small operators in Oklahoma who are tired of paying demand charges on their electricity to lift fluids, and they're looking at battery-backed solar in order to do that. We are seeing, as the fourth industrial age blooms, we're seeing water being managed in the Bakken by blockchain. We're seeing people, instead of flaring gas in the Permian, selling it to Bitcoin miners, creating energy and selling it. So all of these things are ways that we can kind of make that transition in the oil field as well. And the last thing I want to talk to you about before I close is what for me is a really interesting question, because I've done a lot of deep diving into the sort of overview literature in the last year or so to look at energy trends. But what occurs to me is that as things change and we move to an energy model that is completely different from what we're used to in fossil fuels, it is not long scale, high capital investment, high risk, high return. The solar model in particular is very rapid deployment, utility scale returns, low risk, low capital. It's built to go in as DERs, or distributed energy resources. It works best in unelectrified communities where energy is so badly needed, where the picture on the upper left is from India, where small houses are being constructed that are internally complete with solar and recycled water. I think this is from Thailand on the lower right. And the pictures on the lower left are actually from Tulsa, Oklahoma. And the monitor on my phone of our solar panels really brings up the story that of that, of that 5 kilowatts that I was generating when I took this picture, we were only using about a third of it, and our meter was spinning backwards with the rest, taking it off of our bill. Who tracks that? Who tracks all of these small solar installations in Southeast Asia where all of the energy demand is going to go up? Who tracks it? In that upper right photo, that's in Kyamundi outside of Cape Town, South Africa. It's just a Google Earth photo. And you see all the little black specks. Those are solar panels in the informal settlements on the small house rooftops there. And those are not being provided by NGOs or other charitable organizations. Those are the market development for companies like Schneider, like Tata. Those are a market push with financing, cost plus sales, and training to try to electrify the unelectrified parts of the world where energy demand is growing, and to push product in as this solar revolution takes hold. So for me, the thing I really love about SDG 7 is that for all piece, right? And so I zoom in on this to sort of think about, because of the different business model, because of the nature of renewables as so appropriate for distributed energy resources, here is truly a way that we can leapfrog over our archaic grid and distribution system and convert natural resources to energy for all. So this is why I very much agree with Buckminster Fuller that as subsurface geologists in the energy business, we are truly called on to be the architects of the future energy economy. So thank you very much for your time, and we'll move on.